Hello, welcome back to our channel. This week we are going to be solving a requested question from the latest paper 2 past paper, which is January 2025. And the question we are going to be looking at in this paper is number 7. So part A of this question, for part A, you are presented a series of diagrams, diagram 1 to 3, that are composed of lines and dots in a specific pattern. So let's take a closer look at this pattern. Okay, so you can clearly see for diagram 1, there's 1 square. Diagram 2, you have 2 squares. Diagram 3, 3 squares. And we are asked to complete this diagram to give you diagram 4 of the sequence, right? So we automatically know there that diagram 4 would have 4 squares. Okay, so let's look at the lines. We have lines coming out from every direction here. We have one to the left, one to the right, one on top, and one at the bottom. Okay, so let's take a look at the dots. What you can see is a repeated pattern here, where you have, let's look at the top, a dot, a line, a dot. Right, the same thing at the bottom, dot, line, dot. And the pattern continues for every diagram. So from this, we should be able to draw now and complete this pattern for diagram 4 at the bottom here. So first of all, we know that we need 4 squares because this is diagram 4, and we're going to put a dot in the middle because you have a dot in the middle as well as a repeated pattern. Let's complete the lines. We know that we have a line, we need a line at the top, a line at the bottom, and we need a line protruding from the right hand side. Now let's complete the dots. Remember what the pattern is. It's dot, line, dot. So now we have a dot here, line, so we need to put a dot here. And the same thing for the bottom. We have dot, line, and we include a dot here. And there we have it. That's 7A completed. Alright, so moving on to part B. We are given the same information, however this time we are given the information in tabular form. Right, so on the left column we have diagram 1, 2, 3, 4, and we have number of dots which they are representing as D, and number of lines representing as L in your final column. So let's examine the pattern here. So if you just focus on this middle column here, which is the number of dots, we have number 5, number 8, number 11. You can see that it seems like they are jumping by the same amount, right? And for every step, you're increasing by the same amount. So 5 plus what will give you 8? 3. Okay, so we have 5 plus 3 is going to give you 8. And then 8 plus 3 is going to give you 11. So then from this information, we can easily fill out 4. So that just means we have to add 3 to 11. And that is going to give us 14. If you look at this column, the final column here, the number of lines, let's examine the pattern here. We have 8, 15, 22. You will see that it's the same type of pattern where for every step you are increasing by the exact same amount. In this case, it's 7 because 8 plus 7 will give you 15. So then if I add 7 to 8, I'll get the next number. And then if I add 7 to that, I'll get 22. So then it's easy enough to figure out how many lines you'll get for diagram 4, which is what we're asked to figure out for part 1 of this question. Okay, so to be 22 plus 7 is in the same exact pattern, and that's going to give us 29. Right, so this type of sequence here that you are observing in both cases for the number of dots and the number of lines is called an arithmetic pattern, right, which means that every number in the sequence, consecutive numbers, increases by a constant amount. In the case of the number of dots, it is 3, and in the case of the number of lines, it's 7. Okay, so there's this common difference here that applies across the board. So now we move on to part 2 of this question here, where we are only given the number of dots as 59, and we are asked to find which diagram number this is referring to and how many lines are supposed to be input right here. So there are two ways of doing this part here. There's an easy way and a difficult way. The difficult way would be, so we know the pattern here, you just simply add 3 for every step. So you can keep adding 3, 14 plus 3, and then just keep adding right down until you get to 59. And then you do the same thing and figure out how many diagrams, numbers, you have to cover to get to 59, and you do the same thing for the number of lines. Or you can try to figure out the exact relationship between diagram number and the number of dots, and also do the same thing for the number of lines. So as before, let's focus on just the diagram number and the number of dots D. What we want to do is try to figure out what is the relationship between these two exactly, right? So they already gave us D to represent the number of dots. So we need a letter to represent diagram. So if you look down to the bottom here, number 3, they did give us N. So let's just stick with this. Let's just call diagram N. So what is the relationship between N and D? So if you think about it, right? Like if you just think about your tables, you have one, let's use by 3. 2 by 3, 1 by 3 is 3, 2 by 3 is 6, 3 by 3 is equal to 9. As you can see here, in every step here, every sequential step, you're going to be adding 3. It's the same thing that you're getting here. So you know that a multiplication by 3 is happening at every step in this table, right? So let's think about it. Let's look at the first one. 1 by 3 is equal to 3, right? But this number here is not 3 but 5. So how would we get 5 from 3? We can add 2, right? So because this step is the difference between each successive step is the same, that means that whatever constant is being added to get you this number, so if you multiply 3 by n, whatever constant you're adding has to be exactly the same as well, because the difference is the same between each successive step, right? So let's look at the next one. 2 by 3 is equal to 6, right? If I add 2, would I get 8? Yes, you would. So it's the same thing here. If I multiply 3 by 3, I would get 9. And then if I add 2, would I get 11? Yes, I would. So this, therefore, is the relationship between N and D. So what does that look like? So what we have here, I'm going to write it over to the left-hand side. We have 3 multiplied by whatever number N is, whether it's 1, 2, or 3. For this first case, this first column here, whether the diagram is 1, 2, or 3. 3 multiplied by N plus 2, because we know that we have to add 2 in order to get the numbers that we have in the D column, will give you D, not so? So now we have the relationship where the number of dots is equal to 3n plus 2, right? And we could just rewrite it the other way. That makes it easier to understand. Okay, so now we need to do the same thing for the number of lines. What is the relationship between the number of lines, L, and N, which again is the diagram number, right? So let's think about it. If in this case here now we'll be multiplying by 7, right? 1 by 7 is 7, but this number is 8. So what do we need to add to get to 8? 1. Same thing here. 2 by 7 is what? 14. And then you have to add 1 to get 15. And it's the same thing at the bottom here. But 3 by 7 is 21, and then you add 1 to get 22. So the relationship, therefore, between L and N, in this case we are multiplying by 7n, and we are adding, instead of 2, we are adding 1. So we have 2 equations here. Let's call this one equation 1 for the number of dots, and let's call this one equation 2 representing the number of lines. So let's go down to part 2 of this question here, where in this case we are given the number of dots D. So we're talking about the number of dots, so we're referring to this equation here, the one that has to deal with the number of dots. So we're going to substitute here D equals to 59 into equation 1. Okay, so we have 59 is equal to 3n plus 2. And we need to find n because n again is diagram number. This is the first blank in this question here. So how do we do that? We make n the subject of the formula. So if you remember from our previous video, the first thing we need to do if you want to make any subject of the formula is we need to move this plus 2 over to the other side. How do we do that? Because you're adding 2, when you move any term from one side of the equation over to the other side of the equation, whatever you're doing on the original side, you do the opposite on the side you're moving it to. So this becomes 59 minus 2 is equal to 3n. And then we still only want n on one side, which means we need to move across the 3. And what are we doing with the 3 on the right hand side? 3 multiplied by n. So when we carry it across, here 59 minus 2 would give you 57. When you carry across this 3, you're going to do the opposite of multiply, which in this case is divide. So then we have n is equal to 57 over 3. And this of course would cancel. And that will give you n is equal to 19. So we've solved the first part of this, so we know that the answer here, n is equal to 19. So now we have n, but we need to find the number of lines L. And fortunately we have this handy equation right here, and what we're trying to find here is L. So what is L in this case? So we just substitute now our value of n, which is equal to 19, and then we add 1, right? So L would be equal to this, and that is going to give us L is equal to 134. So we just fill that in over here. Our answer here would be 134, and that is the end of part 2. And we have actually already finished part 3, which is asking if the diagram number is n, what is number of dots, and what is the number of lines. So what is the number of dots? Here's our equation right here. We know that the number of dots is equal to 3n plus 2. What is the number of lines? Well, we've also worked out that. It's right over on the right hand side here. And that is equal to 7n plus 1. And that brings us to the end of part B. Alright, so for the final part of this question, part C, I have rewritten the two equations that we just came up with. The first one pertains to the dots, where dots is equal to 3n plus 2, and lines, the number of lines is equal to 7n plus 1. And again, I have called this equation 1 and equation 2 for the sake of convenience. So the question is asking us, for one of the diagrams in a sequence has 148 lines, and we need to calculate the number of dots in this diagram. So whenever you're doing any kind of word problem, any kind of problem, as I always stress, we are going to write the information that we are given. So what we are given here, it has 148 lines. So we have an L value of 148. And what is it asking us for? It's asking us for the number of dots, which is equal to D. So let's start with what we are given. L is equal to 148. All right. So which equation are we going to be dealing with? Well, since we're talking about L, we're going to be looking at equation 2. So the first thing we are going to do is substitute L equals to 148 into equation 2. So let's do that. So we have 148 is equal to 7n plus 1. So again, we just need to make n the subject of the formula because this is the one unknown. So we'll start first with finding n. So how do we do that? We need to move everything that's not n over to the other side of the equation. So we're going to start with plus 1, and because we're adding 1, when we move it to the other side of the equation, we are going to be minusing 1. So that is equal to 7n, and of course that simplifies to 147. Right, so now 147 is equal to 7n. We still need to move the 7, and the 7 is being multiplied to n. So to move that over, that means we need to divide by 7. So we have 147 over 7 is equal to n, and of course these would cancel, So you end up with n being equal to 21. Right, okay, so we did the first part of this equation. Now what? What they asked us for was to find d, right? Remember this? They asked us to find d. So now we have n. We have an equation for d here. D is equal to 3n plus 2. So now we simply substitute n is equal to 21, which we just found, into equation 1. So let's do that. So d, therefore, is equal to 3 multiplied by 21 plus 2. And of course, using BODMAS, we are going to work the multiplication first, which gives me 63 plus 2, which is equal to 65. So are we done there? Are we done there? Let's see. They ask us to find d, and we have d. So yes, we are. So the answer here would be 65 dots. Okay, and that brings us to the end of this question. Thank you for watching, and see you back here next week.